Hi, in this video I'm going to share my view on existing approaches for doing this, and also we will cover some technical details of our solution. The topic is pretty familiar to me because I used to work in a very well-known company which provides portfolio analytics service. Personally, I'm aware about 4 different approaches for portfolio analytics which is applicable to Web3 now. So you can see them on the screen. Off-chain portfolio analytics, it can be Excel or Google Sheet and some APIs. It can be on-chain analytics with third-party RPC node provider, and can be on-chain analytics with your own node. So let's take a look at each of the approaches. So the first thing is off-chain portfolio analytics tool, like CoinMarketCap portfolios or CoinGecko. They are very easy to use, and also they provide theoretical portfolios, so there is no proof that you actually own these assets, so your privacy is preserved. Unfortunately, if you are using these services a lot, your portfolios or theoretical portfolios are evaluated and tracked by the company which owns the service. So they're trying to find the best portfolio managers who are kind of for free giving some insights for them, so they can use this data in their own businesses or day-to-day activities. Also, you have to enter all of the transactions manually if you are going to use it really as a portfolio tracker, not just as some theoretical concept. It can be, I think, linked to your real portfolio, as in case of debunk, but in that case, the pro number 1, which is about no proof that you own these assets, it automatically disappears. The second approach is to use Excel and some APIs. I'm not really familiar with zero knowledge proof concepts, but you are getting only half of the data from public sources, and another half you keep it in secret. So you're keeping amount of tokens you own in secret, and by secret I mean it's Excel or Google Sheet. You may distribute these tokens to different portfolios and no one really knows and can link together your wallets, but you know them all. And then you are using some APIs. It gives you almost 100% of privacy, but there are some issues. So usually most of the APIs, they don't support small capitalization tokens. And right now I'm talking about APIs again, like CoinMarketCap, CoinGecko, or Binance. So these APIs you can easily integrate with Sheets because they are available via simple HTTP requests. I'm not saying about something more sophisticated. That's the probably we will discuss it in the slide number 3 or 4. The price in APIs is also theoretical, meaning that if you are trying to avoid using centralized exchanges, for example, but API will give you the price on the best exchange. So you are making an assumption that you will have to transfer your tokens to this exchange. It can be like some exchange which you are not using very often, you don't have KYC there, or it's even prohibited for you as a, I don't know, some people of some nation to be using exchange, which is another one. Like no one is using Binance US because it's only for US, United States citizens. So all of these things, this API just don't know about this. And another thing, in terms of rebalancing, well, you are entering transactions manually again. You're doubling your job. So the next approach is we're getting closer to the better privacy. And the next approach is to use full Ethereum node provided to you by some third-party provider like Infura, like Alchemy, and use this node somehow in your, again, something closer to Google Sheets or Excel. So if you do some coding exercises right, it will provide you automatic portfolio tracking, which is nice, but amount of development you have to do is, again, pretty high. So there is some risk, although I have to admit it's pretty low, that your RPC node provider can de-anonymize you. So just keep this in mind. Also, as we discussed earlier, the price is not what you really will get if you will swap your tokens on your Ethereum wallet immediately. And here we are coming to the approach which we are going to use in our RayTie project. It consists of having your own full Ethereum node, although it's not a mining node, it's just a full node which contains all of the transactions. And using this from your, again, scripts or Google Sheets or whatever. This gives you 100% privacy because no one knows what you are querying your node for. It's completely yours. You can be kind of honest with it and say, hey, track this, and this wallet. It is where my assets are. Like the sum of the tokens on these wallets is my portfolio. No one would know this. In the next part of the video, we are going to implement this solution. So we are going to use Ethereum full node implementation, which is called Akula. Write some scripts to query data from it to get the actual price, your current portfolio, denominated in different currencies as well. So as I mentioned earlier, the first step in the process will be installing akula Ethereum node, which I would emphasize again. It's not a mining Ethereum node. It's just a full node for storing and querying the data. This is the project's homepage. You can take a look at this. This is some important information about the requirements. So it takes about 2 terabytes for mainnet archive node. Archive full node can be bootstrapped in under 3 days. So I have checked it by myself. The storage actually is about 1.7, 1.6 terabytes. About the hardware, I tried it on different setups and I found this one. This is like 32 cores AMD Ryzen 5 950 with 128 gigs. It took about 24 hours to synchronize using this hardware, so it was really fast. And right now you see it really just wastes time and doesn't do anything. So I think it was very useful for me to bootstrap and start playing with akula sooner rather than later, but right now it's pretty energy inefficient. I tried to use less performant hardware with, I think it was about 8 CPUs and 32 gig RAM, and I wasn't able to synchronize it. It got OMM kill and it got issues with not enough memory. It was very slow to synchronize. So in 5 days it wasn't in the position to which this very high-end server moved in 20 hours. So I'm going to use this server. If you're not really familiar with the prices about the server, so renting this thing costs about 100 euros per month in Germany. Back to our presentation. Let's take a look at the installation process. I already did it 3 times. That's why maybe I will be doing some comments during the installation. Although the server we are going to install it's completely empty, so the guide will be fully reproducible on your empty host. Definitely, if you have something else on it, then yeah, you may have some issues. Let's take a look. And this is the installation process. It's really relatively fast. It will have only 5 commands and maybe a couple of extras, but it's not that sophisticated. The thing which I wanted to mention is on my server, I have Ubuntu 22.4. Although it is this server, I tried it on different versions of Ubuntu, like 20.04, I think, though. The commands are slightly different, but the process is more or less similar. Yeah, let's start with just following what we have in the installation guide. So the first thing we are doing is apt-get update. So what this command is doing is fetching information about all of the packets from the network, because when you are just starting on the clean server, it comes without knowledge what software exists in the world. So we are just installing it. The second thing is to find the version of Clang which comes with your repo. So I'm doing apt-cache search Clang and just scrolling up a little bit. So usually it can be Clang 14 or 12 or 11, whatever, but definitely I'll use the latest one and installing it. So the apt-get install Clang 14. Also, we need to install CMake, Keith Core, and there will be a couple of more packages we need to install. So yeah, the next thing which we need to install is this libxt library, installing them as usual. And we also need to install Rust. Just go into official Rust website, rustlang.org, and getting the instruction to install Rust, running it. Package config is another thing we need to run. So let me show it to you once again. So we just installed, we copied the command to install Rust, but it didn't run it. Second thing we ran was actually installation of package config, right? Apt-get install pkg-config. After that, we pasted the command for Rust installation we had in our clipboard. To install Rust installation, I'm usually changing some defaults. I'm using nightly toolchain instead of stable. I haven't tried different, so maybe it will be fine with stable, maybe not, but I'm using nightly and things work with it. And now it's time to just check out akula, git clone, change the directory to it, building it. Yeah, cargo, you have to source cargo and sure, and build it. It takes about a couple of minutes to install all of these things, yeah. So, and this is the first problem. It is that like some of the packages are expecting C++ as a name of the binary, but we have a clang. So we need to use update alternatives command to create a link kind of between C++ and clang binaries. So let's take a look here, update alternative. So I'm doing update alternatives command to create the link between C++ and clang. Take a look at the syntax. So update alternatives, install C++, USRB in C++, USRB in clang 14. So we need a command update alternatives. For doing so, we need a command update alternatives, and we are saying to it that we want to use clang 14 binary as an implementation for C++ binary. Yeah, so got it. So we are using clang 14 to provide USRB in C++. Nice. Now you can see we are doing C++, we're typing C++ as a command, and it says clang no input files. So we updated this alternative. Immediately, there will be one more issue, because I installed it 3 times already. We have to do absolutely the same, but for CC binary, like C compiler, I think, the old one. Yeah, and continue building. So it failed again because now it wants to have a clang binary. We are using exactly the same update alternatives command, but right now we're doing this for clang. Let's take a look at this command. So sudo get alternative install usr bin clang usr bin clang 14. Yeah, so we are using clang 14 instead of clang. Updated the alternatives, continuing the build. It takes some time. The video here is a little bit accelerated, so it actually takes about 20 minutes or so. Don't worry if it doesn't work as fast on your host. Fine. And now we are running Tmux, because if you're running a long-standing application without Tmux, it will be killed immediately after you disconnect from the server. So the server tracks who is running heavy applications, and if the user is disconnected, then they just killing this application, and Tmux prevents you from this. So we started Tmux, and inside of Tmux we will run the akula node. Let's run it. It's pretty straightforward. Just need to provide data dir. I'm running it as a root because I'm the only user at the server, and the server is only dedicated for this specific task to run the node. It can be dangerous, but I don't see how using not root user can help me with it. Up to you. So maybe you would like to run it as a average user. And right now, yeah, you can see that Kula has connected to peers and started downloading chains and all of this stuff. We can leave it like this for, again, something around 20-30 hours. So it will download headers, download bodies, execute and emulate the bodies, check everything, and it will get to the state how it is right now. So this is how it would look like in, I don't know, about 40 hours. You have everything done, finished, blah, 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 stage completed. So yeah, this is the running node, how I have it right now. 20 hours later, our akula node has successfully fetched all of the blocks, all of the transactions from the network, And right now, as you can see, it fetches every new block every 10 seconds. It's time to start RPC server because it's not included to the main akula binary. It has to be started separately as a separate application. So we are starting it by running this command. Good. I wrote a simple Python script just to show how to connect to it and how things work and to explain a couple of details about it. Finally, I wrote a simple Python script to demonstrate our approach. So we are going to work with these two tokens which are located on this wallet. So you should replace it with the list of tokens you have in your portfolios and to the list of wallets you are using to hide the whole contents of your portfolio. Then the next line is in Fura URL. We are replacing it with our local host URL where Akula RPC server runs. Token ABI and off-chain Oracle ABIs, you can take them from 1-inch documentation page. This is spot price aggregator, maybe examples. Yeah, and you have these things here. So this is just this ABI and address also taken from just from the documentation. Now we are creating HTTP provider which will connect to our Akula RPC server, checking that it's connected, and creating a proxy to access the spot price contract. So we are iterating over the tokens. For each of the token, we are computing how much tokens do we have in total for on all of the wallets. So we are setting total to 0. We are creating, again, the accessor to the contract, which is located on this token address and has token ABI as an ABI, iterating over all of the wallets and adding up total. And then we are using our spot price contract, which is provided by 1-inch, to get rate between generally your token address and ETH. And then let's print token address, total rate. So this is all great, saving it, running. You have to have I think Web3 library installed to make this code work. So it's just like Python pip install Web3, that's it. It's running it. So this is our token address, quantity, and rate. These numbers look pretty big comparing to other scan. Let me try to explain exactly what happened here. So we had so this is the portfolio, how Scan thinks about it. Oh, yesterday it was only 7, today it's 9. Someone is doing great things. So yeah, here, for example, Diffract has this address 064, and according to Scan, it is 3000 tokens. In our case, the same thing, 064, but it is this amount, which is much larger. And the reason why it is like that is because we have a thing which is called decimal. So if we take closer look into this token, there is another thing which is called decimals, which we kind of could have, we should read it generally from the contract, but just for simplicity of our current computations, I would use it. So what decimals means? It means that this number is kind of amount of cents, I would say. So, but in terms of cents is, we can think about it, it's like decimals of 2. So instead of saying I have $10, you're saying, hey guys, I have 1,000 cents. The same thing about decimals, with the only difference that it adds not 2 zeros, but adds 9 zeros in our case. So we are going to address this. And for the second contract, 0xBD0, it is this one, 0xBD0. It also have 9 decimals. So again, if we would like to make it, when we will be doing it right, not prototyping, we will read decimals somewhere here. But right now, I will just do decimals equals to 9. That's for simplicity. And just do fix me. And here I'm doing total divide by 10 in the power of decimal, and let's see how our program changed. So right now this guy has 34 hundredths of 0.64 and still pretty large number, hundreds, millions, billions, trillions, 31 trillion. So let's again check back with thing. Well, yes, it is the same thing, pretty big. So now the next thing is we are computing a rate. So what get rate to Ethereum? What it means, it is amount of Ethereum decimals again for one token of this thing. Let's take a look at the data. This is the price again in Ethereum decimals for one of these. This is the price in Ethereum, like I would say it's called Way, yeah, for Ethereum. Price in Ethereum ways for this. So to get our price of our token, we're just multiplying this by that. Make sense? Yes. Let's say value in way equals to rate multiplied by total and divided by 10 in the power of 19, because this is how many zeros between the smallest item of Ethereum, which is called way, and 1 Ethereum. So 1 Ethereum equals 10 in the power of 19 way. So, and let's print this as well. This is actually not right. Somehow, I mean, it's obvious that we have to divide rate by 10 in the power of 9, and things will look reasonable. Sure. The question is what this thing means. So what they're doing in documentation. You have numerator, which is token decimals. You have denominator, which is Ethereum decimals. Right. So how are you computing the price? And it looks like it's the price in way again. So you are multiplying by numerator, dividing by denominator, and then dividing by denominator kind of again. Okay, so it's not as we, I mean, it gives the right answer, but it does it in the wrong way. So we have ETH decimal equal to 19. Here, according to them, we have to multiply this by 10 in the power of decimals and divide it by 10 in the power of ETH decimal. But on the other hand, we are later on we are multiplying rate by total. So instead of doing this division, so total divided by 10 in the power of decimals, and then we will be multiplying by rate, and rate does this multiplication as well, right? So we will just do it easily. Remove this and remove that from the rate. And to keep the variables clear, multiply by 2. So I think that will give us the right answer as well. Columns appeared. Yeah, it's okay. It computes the value of things in our portfolio in the right way. I would say in a slightly right way. Here we did everything right, and results are absolutely the same as if we would use APIs without providing anywhere our token holdings, rather than just multiplying it on our end. But now we have one more complication, which is very important to keep in mind. And in this video, we are not going to address them, but we will open the conversation for the next video. So again, what we're doing, we are taking this 3445, multiplying it by price, and we think that this will be how much we can get when we will sell our token. 3455 multiplied by 0.16, and this is 5520. I mean, yeah, according to this some numbers, blah blah blah. It's close, right? We are at the page of token 0x64. Yeah, so it's Diffract Finance. We can see that we estimate the price to be 16 cents. Let's try to see what will happen with index tools. So if we're going to change one finance, it shows us different price, so not the same as others coming. For some reason, doesn't matter. But let's take a look at more interesting cases. So if we are going to change 10 of this, the price is not becoming exactly 10 times higher, is it? Okay, if 10, it becomes, right? If we're going to change 100, it becomes, see, 1000, it becomes lower. So it becomes less than 10 times more. One more zero, and it became even worse. One more zero, it only doubled. So you changed, if you want to change 10,000, you're getting $100. If you want to change 100,000, you're getting only $200. This thing is called impairment loss. And if you are owning some small capitalization tokens, it's very important to keep this in mind. And unfortunately, the solution which OneInch provides is not able to deal with this situation, so they don't take into account the size of your deal. It only works for very, very small amounts of tokens when you would like to swap them to Ethereum. Yeah, so we will think about how to address this issue in our next video. Yeah, thank you.